Hi everyone, in this video we're going to discuss a problem called Maze. It's from 2008 CCC senior contest. It is a senior 3 question, so it's supposed to be not super easy. So I have already done this problem, so I know this problem is related to BFS, and that's the main reason I'm doing this video on this question. So before we get into the problem, let me do a review on BFS. So the BFS is a technique you use to traverse a graph. If you want to find the target, maybe it has value of 9, and the shortest path to 9, shortest path. The technique you should use is BFS. So what is mean for BFS? It is just going through the graph in order of exploring level by level, like this. So you explore the root level first, then you continue. You explore the second level. From the second level, you explore. You just track down all the children nodes, connect to the second level, and explore those children nodes. After that, okay, let's get back to the problem. I'm gonna firstly read the problem, then we're gonna try to solve it. In order to make a few dollars, you have decided to become a part of a scientific experiment. You are fed a lot of pizza, then more pizza, and then you are asked to find your way across the city on a scooter powered only by pizza. Of course, the city has a lot of intersections, and these intersections are very controlled. Some intersections are forbidden for you to enter. Some only let you move north and south. As you leave the intersection, others let you move only east and west as you leave the intersection, and the rest let you go in any compass direction, north, south, east, and west. Thankfully, your scientific friends have given you a map of the city. On the back of the pizza box, with an arrangement of symbols indicating how you can move around the city. Specifically, there are 4 different symbols on the box. The symbol plus indicates you can go all 4 directions. The symbol dash means you can go left and right. The symbol straight line, up and down. And the symbol star, you're forbidden to go anywhere. Your task is find the minimum step to take to travel from the top left to bottom right. The input specification is basically I'm just gonna read. The input begins with the number T on its online, which indicates how many different cases are contained in the file. Each case begins with the number R on one line, followed by a number C on next line. And as you can guess, R means row number and C means column number. The next R line contains C characters, where character is one of plus, star, dash, and straight line. Yumi assumes the northwest corner of the city can be occupied. So let's try to take a look at one test case. So let me draw this one because it's pretty easy and small. Let me just change the color, it's too light. Okay, so you can move from this one, you can only move horizontal, so you can only move here and go down. So in total 3 intersections. Not 3 steps, it's 3 intersections. You can do this operation again if you don't quite understand. Okay, so my thesis of this question is just implement BFS. The top left is the starting position, which has the coordinate of 0, 0, because our index of array or vector start from 0. And the bottom right will be, let me change the thickness, row -1 and col -1, because it's bottom right, so it has the biggest column number, and row number. So let's say you have blah 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 nodes, and you're just trying to find a node that contains row -1 and the column -1. And the way you can verify the connectivity between two nodes is the characters. Yeah, so let's just get into the IDE and the actual code. Sorry, I forgot to mention, there's other important thing to notice is once we visited a position, we have to use some technique to let the computer know we have already been there, so we don't have to go back there again. This is because we don't want to get in an endless loop, or we don't want to visit a place again, because then the calculation itself is meaningless, because going back to where you come from doesn't give you the shortest path. However, we are just trying to find the shortest path. Okay, let's get back to the code. So my code is in C++, which is a cool language. I like it because it's pretty fast. So don't get afraid or worried if you are not familiar with this language. This language has really similar syntax as Java. The main difference I noticed is just you don't use scanner, you use cin, and you don't use ArrayList, you use vector. So just imagine vector is ArrayList. It may help you to understand. So I use a for loop to calculate all the test cases. So in each test case, I just taking the input of row and column. I create a maze to just taking all the inputs of the maze. Okay, and I use pair to represent my positions. It starts from 0, 0. The pair is nothing special, but it's just imagine it as an array that has length 2. So the first in the pair, the first number represents a row and the second number represents a column. I created two vectors to contain all the positions, one called BFS, one called new level. So BFS is just the current level we are exploring, and the new level is the children of the current level. So if our current level is root, so our BFS will be here, and new level will be here. Our new level will record all the children nodes from BFS. So once we done the operation, we just move BFS. We assign BFS as a new level, and the new level will record the children of this BFS level. And our output should be the minimum intersections. Oh yeah, intersections. So in this case, we're just gonna output our level number, and that will be just the intersections number. So if you're asking steps, you have to -1 because it takes one step to travel from between two nodes. But to travel from two nodes, it just contains two nodes. I hope it's understandable. Never mind, let's get back to our code. So in each iteration, sorry, I forgot to introduce these two things. The counter is the level counter. It counts the level number, and I created a Boolean variable called a way out. It is a way out just represents. It just keep track if we have found a path to the bottom right. Because why it's important? Because we have to output -1 if I couldn't find a path. And we're gonna use a while loop as long as there's something to explore. It means we have not run out of passes, so we're just gonna do. As long as BFS size is bigger than 0, it means there's still possibility for us to travel to the bottom right. And we're gonna clear out our new level so it can record out the new children's, and just clear or clean out all the leftover children because it's already included in the BFS. We're gonna go through every element of BFS. We're gonna verify if they are the bottom right. If they are, we're just gonna output and set a way out to true. If they are if they are not, it means they are on their way. Maybe they are on their way, potentially. So we're gonna use a switch statement to explore their children. If it's a star, it means that place cannot be visited. I mean, you cannot travel to anywhere from that position. No, it cannot be visited. So it's gonna break. If it's go up and down, which is gonna go up and down. If it's a dash, then we're just gonna go try dash. If it's a plus, we're just gonna try plus. Yeah, you may say, well, that's a lot of code. Why you just say it like in a second? Yeah, I can explain. So there's two things you should verify. The first thing you should verify if it's able to go there. So if you have been there or it's a star, if they are not good, we're gonna verify another thing. Actually, we're gonna verify this thing first. So we're gonna verify if it is still inside the index bound. So if it's outside the bound, maybe it's like your vector is only 3 in length, but your index or your coordinate, your node row number is already like 6. Well, it will cause computing error, and that's not good. That's gonna break our program. So we're gonna verify if it's inside the bound, and we haven't been there, and it is now the star. If those conditions are good, so we're just gonna push our pair of the new coordinate, and we're gonna do almost the similar operation to all the potential children. So yeah, I'm gonna explain why it's r plus 1, r minus 1. R plus 1 is increments the row number by 1, which is moving down. R minus 1, which is decreasing the row number by 1, which is moving up. So similarly to column number, column plus 1 means move right, and column minus 1 is move left. And we still need to verify if they're inside the bound, and we haven't been there. If those things are satisfied, so we're just gonna push them back to the new level. For me, I just copy paste these 4 lines to the plus because they can go up, down, left, right, or north, south, west, and east. And after we do those operations, we gotta set the maze current position to star, so we don't have to go back here again. It just tells the program we have already been here, and it is forbidden to visit here again. After we have done a whole bunch of operation, and we're just gonna assign BFS to new level vector. It means we are moving to the new level, and increment the counter by 1. So if there is a way out, if there is a way to the bottom right, we already found it. Otherwise, if this condition is never reached, if this code is never executed, then it means there's no way, and we're just gonna output negative 1 because we didn't have a chance to set a way out to true. So because initially it is false, then if it haven't been set to true, then it will be false here. We're just gonna output negative 1, which means that place isn't reachable. So let's try to run our sample program and try if it works. Let me drag down so you can see. There's a little problem. I have to click enter one more time. Yeah, but all in all it's working. So let's try to put our code in DMOJ to grade. Yeah, and as you can see, also test case passes, and it's a pretty good time. So let me do some conclusion here. So when a question asks you to find the minimum step to reach a particular position, the first thing should come up to your mind should be BFS, and it usually is BFS if it's a graph theory. And other than that, you have to be careful with those conditions. And other than me just exploring level by level, like with nested loops, you can also use the single loop with a cube, but you need to track down how which level you are on, or how many steps you took, so you won't lose track. But my solution is not the only solution. I encourage you to work on your own and try to solve this question with your preferred language. So I hope you learned something from this video, and hope to see you next time. Bye.